We have exercise 5 from the Essential Skills chapter of Heinamann Higher Mathematics. Looking at completing the square, something comes up in National 5. A few different ways of teaching this, so this may not be the way you've been shown before. What I'm going to do is link it back to expanding bracket squared. So what we should know from exercise 2 and from our National 5 work, if we have bracket squared, we can essentially square the first term, square the last term, and multiply the two terms together and double them. So we'll always get x squared plus 2ax plus a squared when expanding x plus a squared. Why is that? So remember guys, doing the old FOIL thing, first x squared outside and inside are both ax. So here when we've done x times a or a times x and doubled it, that's why we do it, because we're getting that term twice. And then a times a is a squared at the end. So this, going straight to the answer, most of you will probably like, because could put it one way, quite a lot of pupils like to be lazy, or we could say we prefer to produce more elegant, efficient solutions. You can choose which one you want. So let's apply this to a few examples. So x plus 9 in the bracket all squared. Square the first term, x squared. Square the last term, 81. 9 times x is 9x. Double it, 18x. Again, the reason why we're doubling it is we're doing x times 9 and 9 times x when we do the FOIL thing. Same thing here. Square the first term, square the last term, so 4x squared plus 9. And we'd also have 2x times 3 and 3 times 2x from our outside and inside terms, so that'll be 12x. So we could have done 3 times 2x, then doubled it. Same again here, 3x minus 1 all squared, so 9x squared when we square the first term, positive 1 when we square the last term, minus 1 times 3x is minus 3x, double that for the middle term of minus 6x. Right, if you didn't do exercise 3 question 2 that way, go back for 10 minutes now, do a quick bit of practice on it, otherwise this stuff that we're going to do will probably not make as much sense as it should do. So each time here, for example, if I've got 18x, if I'm trying to work backwards, I could just half it and I'll get the 9. These two doesn't really apply as much because we don't have a single coefficient of x. But essentially, again, here we've got 2ax in the bracket, we've just got a. So we are going to try and complete the square, which means put it into bracket squared plus or minus something on the end. So I've got to write it as bracket squared, then either plus or minus something, because the q could be negative. You know, if you add in negative 2, it'd just be subtract 2. So here, what I do, I know it's x squared, so it's going to be x plus something in the bracket. To get that ax, because it's bracket squared, it has to be plus 4, just for the same reason as we're getting this up here and this up here. So I know this part of it is going to be x plus 4. So I'm just thinking, well, what does x plus 4 all squared actually look like? That would be x squared plus ax and square the last term plus 16. Okay, so this bracket squared on its own gives x squared at ax at 16. But I want to write x squared at ax plus 3, not plus 16. So I have got 13 too many here. So I'm going to have to take x plus 4 all squared. I'm going to have to subtract 13 off it to get what we originally had. Okay, so basically bracket squared comes to x squared plus ax plus 16. But we've only got x squared plus ax plus 3, so we need to subtract 13 from the end of it. So I've put an a star and I've put another example in. So y squared minus 10y plus 52. Again, just looking at this minus 10y here, half the coefficient of y, half the amount of y's would be minus 5. So I know I'm going to have y minus 5 all squared in that bracket. So when I expand that, that's the only bracket I can expand as a square and get y squared minus 10y. I will also have plus 25 on the end. So bracket squared on its own is y squared minus 10y plus 25. But I'm rewriting y squared minus 10y plus 52 So I'm 27 short, so I need to add on 27 to this to get the terms that are given in the question. So again, taking that, I want the what's above it, I need to add on 27. Right, part B, a little bit nastier because I've got a negative x squared term. So basically, I'm going to take out a common factor of -1. So it'd be negative bracket x squared minus x minus 4. Then I'm just going to do what I've done up here in A and the A star example. So here I've got -1, so I need to half that coefficient. So that'll be minus a half. So it'll be x minus a half all squared. So that'll be x squared minus x. And don't forget to square the last term plus a quarter. So I've got the negative of all of that. Again, because I've taken out the negative sign here. Now, what I'm going to do next, I'm just going to multiply through by this -1 at the front, just so I can compare it to the original, what we had originally in the question. So I have a quarter, they have 4, I've got the plus x, I've got the negative x squared, so I've done most of it right. I just need to find out what to add on to make 4. So I need to add on 3 3/4 there. So 4 plus x minus x squared can be written as negative x minus 1/2 all squared plus 3 3/4. Let's see. Write this in the form a bracket squared plus q. So I'm going to have a coefficient at the front here. I know if I expand this x plus p all squared, I'm going to get x squared at the front. They've got 3x squared, so it's not too much of a push to know that it's going to be a 3 at the front. So I'm going to take a common factor of 3 out of everything, so I'm going to have 3 times bracket squared here. So taking out 3 as a common factor. I could have taken out 3 as a common factor here, but I know that this is the only part that I'm looking at to get this next line down here. So I'm just minimizing the amount of work I have to do. I mean, it's easy enough, it's 2/3. 3 times 2/3 is 2 wholes. I'm just showing you don't have to worry about that term. So I've taken out 3. This part here, I can get most of that from x plus 1 all squared. So let's have a think about what 3 bracket x plus 1 all squared looks like. That's just 3 lots of x squared plus 2x plus 1. Again, multiply all of this out just to see what this actually looks like in full, and then compare it to what we originally were asked to put into the completed square form. So I've got 3x squared plus 6x plus 3. They've just got plus 2, so I've got 1 too many. So it'll be 3 times x plus 1 all squared, subtract 1. Right, hopefully that made a bit of sense to you. Have a go at exercise 5. If you prefer the way that you were shown in 4th year, just carry on with that way. I just think this way is a little bit easier, it's a little bit less technical, but it also makes a bit more sense. As long as you can expand a double bracket, then you're just kind of working backwards and adding or subtracting. Okay, so exercise 5 on page 325.